Hello. In this video, we will create the models for this example of internal flow between two parallel plates. Okay, this is our geometry. Okay, the inlet height is 1 meter and the length is 10 times of the inlet height. And for the thickness, okay, in this case we will use model for the two-dimensional simulation. Okay, in this case I will generate the thickness is about 0.1 of the inlet height. Okay, come back to the step of the simulation using the SC theta. Okay, in the step of the preprocessor, in this case loads the model data. Okay, in this case we will generate the model using the SolidWorks. Okay, and then we will generate the model file in the name of .step. Okay, and then we will export the step file to generate domain. Okay, for this video we will consider in this step. Okay, open the SolidWorks file and we will generate the geometry of this problem. Okay. Okay, open the SolidWorks and click to generate the plot. Okay, in this point. Okay, we will set the original points of the model in the at the center of the inlet face. Okay, we can show the front plane of the SolidWorks. Then I will sketch by using the rectangle, the corner rectangle sketch. Okay, I sketch here, and then we can add the relation of the middle of this point coincident with the original. Okay, we can do by first right click on this line and select the middle, and then click Control on your keyboard and click at the original, and then we can select the make coincident. Okay, this is the first step. We can define the original points of our models, and then we can make we can define the dimension of our fluid domain. Okay, and in this case we can use it in the sketch mode and select the smart dimension. Okay, between the top and the bottom line we can define the inlet height diameter is equal to 1 and m, this is 1 meter. Okay, and then the length of this model is 10 times of the inlet height. We select this one and we can pi is 10, height is 1 meter. Okay, 10 m, 10 meter. Click enter. Okay, now it's finished. Right now it's finished of generate finished for sketch two-dimensional sketch. Okay, and then we will generate the fluid domain by using the feature, and we will use the extrude boss bed. Okay, in this case I will use the direction 1 and I will use the mode for the mid plane, right, for the mid plane. Okay, consider this one for the mid plane, and the thickness. Okay, do you remember that we will use about 0.1 of the inlet height. Okay, in this case the dimension we can select 0.1. the height is 1 meter. Okay, this is our domain 3D model, right? Okay, we finished in the step of the generate the model in the SolidWorks, and then I will save file, right? I will save file. The first I will save file in this name, exercise 1 at SolidWorks, and then I click save. Yes. Okay. Do you remember that for simulation, the step of the simulation? Okay. In this case, you should to save the model of save file, the CAD model of the SolidWorks. We should to save in the step file. Okay. In this case, we can do by using the following step. Okay. We can click file and the menu bar, click file, save as, and then I will click. Okay, you can use this the step file, step AP214 dot step. Okay, this type. Okay, I will set the step file in this SolidWorks step is okay. Okay, return to your folder directly. Okay, and then you will see. Okay, I will remove this one. Okay, now we have two files. First, the CAD model of the SolidWorks, and the second is the SolidWorks or the model, the step model. Okay, now we finish in the step of generate the model using the SolidWorks, and the next step we will go to ST key to generate the model file. The model file of the SC of screw tetra or SC tetra is .mdl. Okay, and the next step we will generate the model file of .mdl file. Okay. Okay, go to the next step. Okay, go to the next step of generate the model file in the screw tetra. Okay, the first time of your simulation using SC tetra, we can find the program, click the window, and then we can find the group of photo of the Cardo, right? In the Cardo software, okay, you will see this this software SC Tetra. In this version is version 14, and then you can click. Okay, this is our SC. The name of this one is called SCT Kicker, and you can see in this item is for the P processor, and this item is for calculation, and this is item number 3 is for the post processor, and A, right? You can see the basic, you can see the manual, or you can see the many document for using the SC data. Okay, for example, if you want to see about the basic CFD analysis, you can click on the clicker about this one, basic of CFD analysis. Okay, you can see this one is the this document which show the fluid analysis system with unstructured, okay, unstructured generator of SC Tetra version 14. Okay, and you can see many. Okay, this is the document, and also you can see the exercise, right? You can follow the tutorial of the software by set up following the tutorial, right? For example, okay, in the function one, turbulence analysis, okay, and you will see this is the your model analysis. You can set the inlet, outlet, and you next step. Okay, this is one is for the simulation setup, and you can see this is the step of generate the octave file, then generate the mesh file. Okay, and this is the in the post processor. Okay, okay, this is you can see the this document in the exercise. Okay, and you can follow and you can learn by yourself by following the exercise of this software. Okay, come back to our problem. Okay, the next step we will generate right here. Now we locate it in this position. Okay, open this P processor. Click here, and you can. Okay, this is the STP. Right, this is the SCP window. Okay, for the SCP window, you can see this one, right? We can okay the SCP. Okay, in this is the T, this is the menu bar, and this is toolbar, menu bar. Okay, and this is the door window, and this one is door window. This is the message window. Okay, and you will see. And for using the mouse of uh, your user, okay, actually in uh, the mouse operation depend on the type of your mouse. Okay, actually our mouse is the T bottom mouse, and you can use, for example, if you want to select the model, you can click on the right bottom. Okay, in you want to use the pop-up menu, right click, right, rotate, middle click, and drag, right. If you want to enlarge and contract, you can right click and drag. Okay, if you want to move the middle, and right click to the rotate. Okay, click shift on the keyboard and mod on and the bottom and the middle bottom and drag. Okay, this is okay, and this is highlight for your using in the kernel. Okay, this is the outline of the kernel. Okay, return to. Okay, after you open the HTTP, you can see this one this is the main menu bar. This is the key. This is the tool. Right? Open, save file, and this is the method. Okay, the first step we can generate. Right? We can generate. We can create the model file by drag the step file, right? Drag and drop to the SCP. Okay, and then please wait. Okay, in this step is called the apply mode. Okay, in the first of the apply mode, this one is for prepare the path. Okay, and you can see this our file name. in the by C. This is the file directory location. Okay, and the file information. This is our file information, the step 5. And in this step, we can add to analysis model. Click. Now it's including the transform step 5 to the model. Okay, and you can see the model data definition of the units. You can see the site, right, in the X, Y, and Z dimension, right? The X dimension is, you can see this is the X dimension is 10 meter, and Y direction is 1 meter, and that the thickness is 0.1. The unit is meter. Okay, and you can see the original of the origin, right? The origin of this model is located at the coordinate x, y, x, y, c are 0. Okay, depend on our generate. Right? Do you remember that our generation of the model file? Okay. Click OK here, and then in this step, you can see the function for prepare the part. Okay. Now we can click next. Okay, in this operation about the create the MDL is the model file, right? In this case, we can click next. Okay, operation of the shape group. Okay, and click next again. Okay, now you can see on the T file, you can see this is the width domain, the setup. Now the step of the prepare pass is already done. The merge of MLD is already done, and then we can set the condition. You can click next here. Okay, in this step, I recommend you before we will generate the opt for the mesh. Okay, in this case, we can switch the window from the plan mode to the model mode. Okay, in this case, you can do by go to the map. Okay, this is the plan mode, and then we switch the plan mode to the model mode. Click the model mode. Okay, in this case, we will confirm the file name, okay, of the model. We can click the directory of this one. Okay, in this case, I will set the model file, right? MDL file is the two parallel page or parallel page. Okay, this is the model file, and then click OK. Please confirm in your folder. Okay, now you can see our file including with with many files. Okay, please delete this one. The step SolidWorks file, step 5. I recommend you should to delete the .xt, delete the .hwo. Okay, please skip only T file, SolidWorks, step, and model. Okay, and the step of the model. Now we have, okay, this is our model. Okay, do you remember that? The mouse operation we can use by, okay, Now I want to show you about the how to rotate, right? How to rotate, how to enlarge, and how to move, and how to 2D rotate. Okay, for the rotate of this model, you can follow like this. Okay, the first, if you want to select, right, click. Okay, the first you should to go to the pop-up menu by right click, right? Read the pop-up menu. Okay, pop-up menu, and you can see, and the rotate, the middle, and then middle click and drag. You see that rotate. Okay, if you want to enlarge, right click and drag. Okay, and move the middle and right click. You see the move. 2D rotate, right? 2D rotate. You can use by using the shift and middle. You see the 2D, right? Rotate about set direction. Okay, this is enough for you about the pop-up menu, rotate, enlarge, and move, and 2D rotate. Okay, if you want to see in the view of perpendicular to the x, y, and z axis, you can manage by uh, paste, for example, paste x in your keyboard, right? This is the x direction. Is paste y, right? This is the y direction, and z direction. Okay, this is the basic of using the keyboard and the mouse. The keyboard x, right? Y, z. Okay, this is enough for your uh, first first step. Okay, come back to our model. Okay, in this case, we will generate the fluid domain, right? The next step, we will generate the fluid domain. This is our fluid domain. And the next step, we will generate we will define the boundary name. For example, this one is the inlet and the outlet, top, bottom, and two sides perpendicular to the z direction is y SYM1 and SYM2 is the SYM is the symmetry, right? We will define of the two surface the symmetry boundary condition. Okay, because we want to model for two-dimensional simulation. Okay, return to our model. Okay, please rotate in this direction like this. Okay, this considered in the T. This is the region, right? Okay, double click on the region. Double click on the region. This is, you can see the this is the surface region. We have only one. We can consider this is the coach volume, right? This is coach volume 0 in the outside of our domain, and coach volume mesh number 1. This is the inside of our simulation domain. Okay, and the next we will consider about the surface. This is the surface region. This is the volume region. Okay, we can go to the surface region. This is the volume, right? The volume of of this model refer to the original name of your file from the SolidWorks, and you can rename. Okay, and you can rename this volume. We can rename. Click on rename, and we can rename. We can using the fluid domain. Right, we can use the fluid domain for the volume. Then click OK. You can see this is our fluid domain, and then we can double click on the new groove and none. Okay, this is the default of boundary condition. I recommend you that you should to delete or by click the new groove, control, and then delete. Okay, now we have only a fluid domain, right? Fluid domain, and the next step, we will register the boundary condition, the inlet, the outlet, right? Top and bottom, and two surface of the symmetry. Okay. In this case, the target to register. The first we can use the mark surface. Okay, right click, and then you should to select the unmarked surface, right? The unmarked surface. Okay, unmarked surface. In this case, we can register the region name, define inlet, right? And then please rotate this boundary, and then you can click here. Now you cannot click. Okay, in this case you can do by right click and then click mouse, pick surface, and select mouse, click and sphere, and click here. Now we can select the inlet surface. Okay, and then register. Now you can see the inlet, right, in this domain. Okay, select the unmarked surface. Okay, and the next we will define the outlet, right? We define the outlet in this region. Ties outlet. Okay, select this side is the outlet, and then okay, if you want to if you have a mistake of selection the surface, you can do by click on the surface again, right? If you need to control two surface, you can click on that surface again, or we can do by unmarked surface and then select it again. Okay, this is the outlet register. Okay, this is our outlet, and the next is the top wall. The top wall. Okay, register here. You see the top wall register, and the bottom wall. Bottom wall. Okay, this is the bottom wall register. Okay, please check it again. This is the full domain. The type is volume. The inlet. Okay, outlet here. The top, the bottom. Okay, and mark, and then symmetry 1, SYM symmetry 1 at the surface of the positive set in this surface and register. And the last one. Okay, in this step we can select in this surface and register, or in this step if we want to check the registration of your model, you can check by this method. Okay, you can select the target, the region, and you can select, we can change from the mark surface to I will select the surface specified of specified material. Okay, we have only one material, and then if you want to check this one, it click equals register region, click here and then verify. Okay, you can see only one surface, right? You can see only one surface. Okay, in this case you can change the symmetry 1 to symmetry 2. Okay, click it again, register, and now you can check, right? You can check your model with surface not register list. Okay. Okay, now you can see from the message window there are no, the surface is not yet register list, meaning that the all of surface are register list already. Okay, now we finish in the step of the generate or create the model. Okay, code. Okay, in the T, right? In the T we have, you can see this is the fluid domain, right? Inlet, outlet, bottom, symmetry 1, symmetry 2. Okay, now we finish in the step of the generate the model. Before we will stop, before we will go to the next step of the generate the mesh. Okay, in this case we should to save again of the model. Okay, go to the model on the T menu and then right click, right, and then you can please check the save file. Okay, we can upgrade for the exercise this one parallels and paste, and then save. Okay, we want to replace, click save. Okay, now our model is updated. Okay, we can check. Okay, uh, we can we can after we clear the model file of the SCP, and then we can use this model file to go to the next step. Okay, in this case I will check by create a new file. Okay. This model active file analysis release. Okay, yes, I want to release. Okay, this is the new, and then if you want to use this file, click on the model and then click and drag to the STP, right? In this case you can see your model file, right? Bodily. Okay, now we finish the first step of generate the model. Okay. Okay, now we finish in the first step of the generalist the model by the select verb and then export in the step file and then use the step file uh, to the st sctp to generate the model file. Okay, the model file of sctp is .mld. Okay, now we have the mld file. Okay, this is the first step of generate the model file. Okay, the next video we will generate the method. Okay, by following the second step of generate the octave file and then generate the mesh file. Okay, thank you for your attention of this video for generate the model. Okay, and see you to the next video of generate the method. Okay, thanks.